So when you're thinking about a rational equation, what makes it different from the other ones that we've talked about in that where there's a fraction is that now the variable is in the denominator. So back when we talked about linear equations, there were equations that had fractions in them, but the denominator was always just a number. In rational equations, the variable is now in the denominator. So up to this point, we've talked about linear equations. And remember, we're always looking at the variable to see what's happening to it. With linear, the largest exponent is a 1. We've also talked about quadratic equations. So for quadratic equations, when I look at the exponent or when I look at my variable, the largest exponent is a 2. Now we want to talk about rational equations. Alright, and when the variable could be anything, it could be an x, it could be an x squared, but it is in the denominator, and that is what makes it rational. Alright, in a rational equation, since the variable is now in the denominator, alright, what we have to do is make sure that when we get our solution for x, that it does not make the denominator be 0. Alright, so if I have, let's say, 2 over x is my fraction, x can never equal a 0. Because if I plug in a 0 for x, 2 over 0 is undefined. You can never have 0 in the denominator. Alright, so maybe to keep in mind, you can remember this. No. Alright, numerator, you cannot have the 0 in the denominator. No, but it is okay for the 0 to be in the numerator. Alright, so we're going to keep in mind as we solve through these that the x cannot be, or the denominator cannot be 0. Alright, now what we want to do is we want to first remove the fractions by multiplying by the least common denominator or least common multiple. They're the same. Multiple is what we would say, but you may more commonly hear denominator, least common denominator. Alright, so I want to first remove the fractions. So remember, in removing fractions, I need something that all of the denominators will divide into evenly. Now, you can go through and try and figure out what that would be, but to me, it's easier if you just look at each individual denominator. And you first want to make sure that if you have any denominators that can be factored, that you factor them, because we want to find the smallest multiple. Alright, so you got to know what all the factors are so that you can find the smallest one. So when I look at these two denominators, I cannot factor them any further than what they are. Alright, so to get rid of them, I like to take it one fraction at a time. And I say, what can I multiply by this fraction so that this 2 will divide into something and it will cancel out. And so if I multiply this fraction right here by a 2, then this 2 and this 2 will divide out. So it looks like this. 2 times 2x minus 3 over 2 is what that looks like. And this is the 2 I'm multiplying by. This is the original 2 in my problem. So this 2 and this 2 will divide each other out. Alright, now remember, if I multiply any one thing in my equation, I have to multiply everything by that same thing. So I'm going to go through here and I'm going to multiply everything by 2. Alright, so I've multiplied this fraction by 2, this fraction by 2, and this x by 2. Whole number or not, it has to be multiplied. Alright, now I still have this denominator, so I need to multiply by it. So I'm going to come and multiply by x plus 1 so that this x plus 1 and this x plus 1 will divide out. Alright, I'm going to write that right here. Alright, because I multiplied this fraction by x plus 1, I have to multiply everything else by x plus 1. Alright, now keep in mind why we are doing this. Alright, and the point of it all is to get rid of these denominators. I need something that they will divide into. Alright, I'm never multiplying anything times the denominator itself. Alright, the denominator is always dividing. Alright, so now this 2 and this 2 will cancel or divide out, and I'll be left with x plus 1 times 2x minus 3. And then this plus sign, And then this x plus 1 and this x plus 1 will divide out, and I'll be left with 2 times 5x. And then on this last term, there's nothing to divide out, so everything just gets multiplied together. 2x times x is 2x squared, and 2x times 1 is 2x. Alright, I'm going to notice now that I no longer have any fractions. I divided by my denominator into what I was multiplying by so that they would divide out. Right now I'm going to get rid of my parentheses, so that'll be 2x squared minus 3x plus 2x minus 3, and then plus 10x. Alright, and then there's no parentheses here, so I'm just going to bring that down. Alright, now I want to combine like terms, so I have 2x squared, negative 3x, positive 2x, and 10x would leave me 9x's minus 3. Alright, so now I have removed the fractions, I have removed parentheses, and I have combined like terms. Now I want to see what type of equation do I have. Well, it looks like it's quadratic because the largest exponent is a 2. But if I take this 2x squared and I move it over with this one, notice they cancel each other out. So really, it's not quadratic, it is linear. So what I'm going to do is take this 9x and move it over here with this 2x. So now I have negative 3 equals negative 7x. I'll divide both sides by negative 7 to get x equals 3/7. Alright, what I'm going to do now is check to see, does this make my denominator equal 0? Alright, so if I come back to my denominators, the only one that has a variable is this one. And if I plug in 3/7, 3/7 plus 1 is not 0. So then I can say that this solution is good, at least in terms of not making the denominator 0. Now if you use your calculator and try it out, then it will tell you if you get 0 in the denominator or not. Alright, let's look at the next one. We have x minus 2 over 2x plus 1 equals x plus 1 over x. I'm looking for something that 2x and x will both divide into and divide evenly so that the denominators go away. So neither one of these will factor any further than what they are. I'm going to multiply everything by 2x. So now I have this 2x times x minus 2 over 2x, and then 2x times 1, and then I have 2x times x plus 1 over x. Alright, so I've multiplied everything by 2x, so this 2x and this 2x will divide out. Now looking at my other denominator, I have x. I need something that x will divide into and go away. Well, when I multiply by this 2x, I have that available. This x and this x will divide, and the x in the bottom will cancel out, or it will divide out. X will go into 2x and leave me just 2. So I don't need to multiply by another x. Multiplying by 2x was the least common multiple. 2x and x will both divide into what I've already multiplied by. Alright, so let's do the multiplication here. So this 2x and this 2x will cancel. I'll be left with x minus 2. Then I have 2x. Then this x and this x will divide each other out and leave me 2 times x plus 1. Alright, so I'll have 2 x's, and 1 x makes 3 x's. Then I'll have 2x plus 2. Alright, so I've gotten rid of the fractions, I've gotten rid of the parentheses, and I've combined like terms. Now what I want to do is solve for x. So this is a linear equation. The largest exponent on my variable is 1. Knowing that, I know I need to get this 2x over here with this 3x, and this 2 over here with this 2. So that leaves me x equals 4. Alright, I want to verify that it does not make my denominator 0. So if I come up here, I have a 2x and an x. If I figure out what makes either one of those equal 0, I will find that if x is a 0, and I plug in 0, I will get 0 in the denominator. So my 4 is good. Alright, looking at number 3, we have x minus 5 is our denominator, which we need to go away. So I'm going to multiply by x minus 5 on every term in the equation. Alright, so x over x minus 5 got multiplied by my denominator. X minus 5 was multiplied by 5 over x minus 5, and my negative 5 also was multiplied by x minus 5. Alright, that is the only denominator there is, so multiplying it by it will cancel it out in both places. So here they divide out and leave me an x. Here they divide out and leave me a 5. Nothing to divide here, so I'm going to say negative 5 times x and negative 5 times negative 5 to get 25. Alright, so my fractions are gone. I'm going to combine like terms. Alright, so I put the 5 and the 25 together to get 30. Make sure you bring down negative 5x. This is linear, so I'm going to move this 5x over here with this x. To get 6x equals 30, divide both sides by 6, and then I find that x equals 5. Alright, so if I check my answer, if I come here to the denominator, x minus 5, what would make that be a 0? So if I can solve it like this, and if I move the 5 over, I'll find that if x is a 5, both of these denominators will be 0. So if my x is a 5, it is no good, and it is a 5. So that means that solution is no good, and there's no other solution to offer. That was our only option, and it is no good. So since it's no good, the answer would be no solution.